Let's take a look at another type of exponential function. We're going to talk about growth and decay. What they mean here by growth is talking usually about a population. Population of bacteria, population of people, population of whatever. And the decay is usually some sort of radioactive isotope. You've probably heard of half-lives before if you take in science or any kind of physics. They like to talk about half-lives all the time. Here's a general equation. This is kind of interesting. Now, the A, of course, is just like our investments. This is your initial amount. This is the initial amount that you started with. But what is K? K is your factor. That's your factor of increase or decrease. So if you're talking a half-life, that K becomes a half. If you're talking about when does the bacteria double, that K becomes 2. Or maybe that factor could be some sort of percentage. If it's something like 10%, don't forget, you have to add it to the original amount. So like any good hockey player will tell you, you got to give 110%. There you go. So you're adding the original amount plus the amount that it's increasing by to give you your 110%. Now, what does the B stand for? The B actually is your horizontal stretch, if you think about it that way. Another way of thinking about it, B works out to be very, very interesting. This is your time period. This is your time period that you need to talk about how often does this happen. Okay? For example, if the half-life is 30 days, then you're going to say it is a half-life per 30 days. So this actually ends up being a fraction right here. Just like your horizontal stretch, remember you have to flip this. So you will actually see, oh, and your X would be, of course, the number of days or years or whatever that you're going to put this in for. So this is going to be your time. Okay, so it's very important to realize that you know the difference between period and you know the difference between time. Time is how long it's going to be put into that, let's say, bacteria dish. Time period is how often does this double, or how often does the half-life come in, or how often does the percentage comes in. And don't forget, that's always going to be reflected as a per something. So a lot of people like to write this formula like this. Here's your A, here's your half-life, then you're going to put your time on top, and then big T on the bottom, which is your period. So this is the time it's going to be put into your incubator or whatever it is. So this is going to be your time. This big T stands for something called your period. How long does it take for this to double or half or increase by percent? I think the best way of describing this then, folks, is by doing an example. Here's a beautiful example for you. A biologist places a group of 10 bacteria. So 10 bacteria is going to be your initial amount. And notice that the biologist finds the bacteria increases by a population of 20%. So guess what? There's your K value. Okay, every 2 days it does that. That's your period. It happens every 2 days. So they haven't talked about how long you're going to let this thing multiply for, but it did tell you that your period is this. Okay, so let's start working this out. Remember, you're talking 20% plus the original amount of bacteria, so you're actually gaining by 120%, and putting this into a decimal, it's going to be 1.20, of course. So, all right, let's take a look at this. Y equals to A, K, the time over the period. Okay, so your initial amount that you put in here, 10 bacteria right here, so your A is 10, your K value is going to be this 1.20. That's how much you're increasing by, 1.20. Now, you are also looking at a period of 2 days. So this is going to be T over 2. That's your general formula for figuring out this nice little piece of bacteria. Great. Now, look what it says in the first question. The first question here says that they want you to determine how much bacteria will be in the dish at the end of 5 days. Well, that's simple now that you've got the formula. There's 10. There's 1.20. You're going to put it in for 5 days, and it takes every 2 days, it increases by 20%. That's your period. So how are we going to do this? Well, bring up our calculator here. We do what's in the brackets first. So that's 1.20 to the power, and make sure you put this in brackets, 5 divided by 2. There's your power, there's your exponent, right? That's how much it's going to increase by. Multiply it by your original number of bacteria, which just happens to be 10. And at the end of 5 days, you should have somewhere in the neighborhood of very, very close to 15.8, or better yet, you can't have 0.8 of a bacteria. You're going to have about 16 bacteriums, okay, in your Petri dish. Now, here's an interesting little question now. If you look at B, which is right up here, it says, when will the bacteria reach over 10,000? This is going to be fun because now you have to go backwards here. Let's see what we have to do. Look at your original equation. Your original equation was Y is 10 bacteria. Your increased rate is 1.20 over a time of T over 2. Your problem is now, wait a second, how am I going to find this? Because that's now 10,000 bacteria at 10 times 1.20 T over 2. Well, you know, the nice thing is you could do a little bit of math here to kind of clean this up, and it actually becomes a little bit easier. Divide this by 10, divide this by 10. You're now dealing with 100 equals to 1.20, because of course the 10s cancel, to the power of T over 2. Now, how do you solve something like this? Unless you know logarithms, you really can't. So, how do you solve this? So the best way to solve this is put this in your calculator. Put this here as y1, put this here as y2. The important thing is make sure this is in brackets. So I did that already. Check this out. Here's my calculator. There's my 100, which I've got right here. Okay. There's my exponential function, right? From x over 2, and notice how I put it in brackets here. It's very important that you put it in brackets. Then I'm going to hit graph. Well, actually, let me show you my Windows settings first. I took a Windows setting. Let me get rid of this ink here because it's a little irritating. Okay, I put my Windows settings like this. I put a maximum of 60 days. How do I know it's a maximum of 60 days? I don't know. What I'm looking at here is I looked after 5 days, I only had 16 bacteria. So I think I'm going to really extend my numbers out here up to 60 days to make sure that this works and includes everything possible. Also, I'm looking at 100. I extended my Y max up to 150, and then I hit the graph. Check this out. Let me get rid of this ink here again. Come on, thing. Okay, clear ink. Look what I've got. I've got an intersection point right there. There's your intersection point. There's your exponential graph that goes up here. There's your 10,000 bacteria. We want to find where those two are going to hit. So let's go out and figure this out. Second calc, just like we always did. Find an intersect. Here we go. Enter, enter, enter. And guess what we've got? We've got, look at that. It's going to take 50.5 days in order to get 10,000 bacteria. So in 50.5 days, 50 and a half days, you'll have 10,000 bacteria. And that's how you do these kind of questions.